y equal to a by a by del L by L. This is strength del L by L. Or del L by L equal to F by AY. For same strain, if 1 by A1 Y1 equal to F2 by A2 Y2. Okay, or F1 will be replaced by T1. T1 is the tension for example in steel ware, and T2 is the tension for example in the brass ware. A2 Y2. Okay, or T1 by T2 equal to A1 Y1 by A2 Y2. While A1, Y1, A2, Y2 all are given, T1 and T2 they are not known, and you have to find T1 by T2. Okay, how will you find T1 by T2?
Putting the values.
Putting the values means?
Putting the value A1, Y1, A2, Y2.
No, A1, Y1, A2, Y2 are all known. And T1 by T2, you'll have to get an expression of T1 by T2 in terms of X. Then this equation will give you the value of X. So you'll have to get an expression of T1 by T2 in terms of X. That this rod is in equilibrium. So go back to rotational dynamics.
Delta torque equals
net torque equal to 0. Net torque equal to 0. Good. So we'll apply that condition for rotational equilibrium. We'll apply that condition for rotational equilibrium, that net torque equal to 0. Okay. In order to find the net torque, you have to indicate all the forces which are acting on this. You can see T1 is acting here, T2 is acting here, and mg is acting here. This is the weight of the load, and the problem has stated light bar. That means the bar does not have its own weight. Weight is negligible. So T1, T2, and this is 50 minus x, and this length is x. For equilibrium, since the rod is in equilibrium, for equilibrium of rod, summation tau equal to 0. Okay, let us take torque about this point. So torque of T1 into perpendicular distance 50 minus x equal to torque of T2 T2 into x. Okay, and what will be the torque of this load? 0, because it is passing through this point. So we have taken torque about the point P. So it will be better if I write P in the suffix. We have taken torque about point P, and T1 exerts. For T1 the sense of rotation is clockwise, and for T2 the sense of rotation is anti-clockwise. So we'll get T1 by T2 equal to x by 50 minus x. So this is equation 1 and this is equation 2. Okay. Now
T1 by T2 equals to 4.
T1 by T2 equal to 4. So find x now. From 1 and 2. x by 50 minus x equal to a1 y1. a1 is 0.05, y1 is 20 into 10 to the 11 divided by a2 0.025 into 10 into 10 by 11. So what value of x are you getting from this?
40 centimeter.
40 centimeter. Okay, so this is one answer. For same strain, this distance is 40 centimeter and the other distance is 10 centimeter. Okay, 40 and 10 because total is 50. Okay, now we'll solve the second part of the problem. For that, first we'll write the expression of stress, and the stresses should be equal. Again, T1 and T2 will appear.
Both the lengths are the same.
Lengths are same because it is suspended horizontally from the ceiling, so the length should be same. Y equal to A by A by del L by L. This is stress, or stress equal to Y del L by L. Okay, hence y1 del L by L for same stress y into del L by L. You'll have to find same stress F by A1 means we'll have to use this one directly. Okay, the formula will not be required. Stress expression for stress, all of you know, F1 by A1 equal to F2 by A2. Okay, and F1 by F2, T1 by T2 equal to A1 by A2. A1 is known 20 into 10 to the power 11.
So that one is the Young's modulus.
Which one?
A1 is 0.05.
Oh, 0.05, correct. So this is 0.05 and this one is 0.025. This is equal to 2. Now put the expression for T1 by T2 again. X by 50 minus x, that is equal to 2, or x equal to 100 minus 2x, or x equal to 100 by 3, means 33.3 centimeter. Okay, from this end.